Okay, in these notes for 10.5, we're going to look at evaluating common logs. Common logs are logs with a base of 10. For example, right here we have log base 10 of x. Now this is usually written without the subscript 10. It's always written, or usually written as just log x. The 10 is sort of assumed that if it's not written, if you don't have a base on your log, it's assumed to be a 10. And the log function on most calculators is what's used to evaluate these common logs. So if you see the log button on a calculator, like this one right here, that is what's used to evaluate these logs with base 10. So first, we're just going to practice finding the value of these logs using the log function on a calculator. And we'll round to 2 decimal places. So here we have log 5, and it's real simple. We're just going to say 5 and hit the log button. And it gives us 0.6989, blah, 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 blah. But for these notes, we're going to round to 2 decimal places. So we'll call this 0.69. Now the 9 will round up to the next 10. So we'll say 0.70. I like to have that second 0 so that we know it was rounded. Okay, let's move on. Log 0.3. So I'm going to put 0.3, hit the log button, and it gives me negative 0.52, negative 0.52. Now I do want to point out that what we're finding is the exponent needed to make 10 that number, right? If you remember how logs work. So the log of 5 is the exponent needed to make 10 into a 5. If I go in my calculator and put 10 to the 0.7 power, now I rounded this, so it's going to be approximate. It gives me 5.011. So because I rounded, it's not exactly 5, but you see it equals 5. So the reason we get a negative here for 0.3, and if I put 10 to the negative 0.52 power, I get 0.3019, but it rounds to 0.3. The reason it's negative is because, remember, a negative exponent gives us a fraction less than 1. And so in order to get a number that is less than 1, we have to use a negative exponent. Okay, log 7. Just put 7, hit the log button. Whoops. Make sure you clear your calculator first. 7 log, we get 0.85. Okay, now this kind of makes sense. This is almost 1, and 7 is almost 10, right? 10 to the first power would give me 10. So 10 to the 0.85 gives me a number that is almost 10. So these numbers should make sense if you think about them in terms of they're the exponent you would put on a 10 to get this number. Okay, log of 0.5. We get negative 0.30. All right, now for our next example, we're finding x, and here they're written as exponentials. Right, we have 10 to the x power equals 0.1. Well, remember, we can rewrite this as a log. So log, it would be base 10 of 0.1 equals x, right? So what we're doing is just finding the log of this number. So x here would equal, if I put 0.1 and hit the log button, it's going to equal negative 1. Because 10 to the negative 1 power is 1/10, which is 0.1. So now that we know this, we can just find the log of this number here, and that will give us the exponent that we're looking for. So I can do log of 25. I get 1.397 would round up to 1.40. Okay, 10 to the x equals 100. Now I know here that x is going to equal 2. I know 10 squared is 100, but if I test it out and do log of 100, I do get 2. So that confirms what we know about logs and how they relate to exponents. Now 10 to the x equals 76. Now 76 is kind of close to 100. It's honestly as close to 100 as this was to 10. So I think we're going to be almost 2 here. It'd probably be 1 point, more than 1.5. We'll see. We'll see. Log of 76. 1.88, right? So close to, actually was pretty close to that if we add 1 to it. Close to 2, but not quite. So x here equals 1.88. Almost 2 because 76 is almost 100. Okay, so that's how we use our calculator to evaluate logs. And we can use logs to find an exponent on a 10 in order to get a number we want. So really quick overview on common logs and the calculator. Now, if we have other logs, this is what common logs are really great for. If we have logs of a different base, what we can do is change the base, and we can change it to base 10. So here, if we have some log base a of n, I can rewrite that as log base b of n over log base b of a. And the b can be 10. This is commonly used when b equals 10 to allow us to use a calculator to evaluate. So imagine this b is a 10. What we're doing is log of n divided by log of a. So it's kind of the large number over the small or the base number. Okay, so let's practice this. We're going to evaluate by using the change of base formula. We'll write them in terms of log base 10, and then we'll round. So for log base 3 of 20, we're just going to do log of 20 divided by log of 3. Okay, so this number always goes on top, and the base always goes on the bottom. Luckily, now that we've changed it to log base 10, we can use a calculator. 20 log divided by 3 log. We get 2.73. That's all there is to it. Let's try the next one. We're going to do log 6 over log 8. Right, the big number over the small number. Now notice when I say that, I don't mean the larger magnitude number. I mean the number that is written with a bigger font. The contents of the log over the base of the log. Okay, so log 6 divided by log 8. And I get 0.86. Let's keep going. Log base 4 of 75, I'll change that to log 75 over log of 4. And we'll just use the calculator to figure this out. We get 3.11. Last example here. Log of 270 over log 3. Oops. Got to clear that calculator. Log 270 divided by log of 3. 5.095 will give me 5.10. Now you got to be really careful when you're doing these logs, because if you make a mistake typing it into the calculator, you're not really going to know. There's no great way, especially with these change of base formulas where you're dividing two logs, there's no great way to immediately know that your answer seems wrong. Typically, if you've got a big number on top and a small number on the bottom, you'll have a number greater than 1, but it is hard to predict and know exactly what your answer is going to be. So just be really careful when you're typing these into your calculator. Make sure you type everything correctly and in the right order, and you should be okay. So the log button, log function on your calculator is how you use, how you evaluate common logs, logs base 10.